Assalamualaikum and hi everyone. Today we will talk about a few topics in operating system. My name is Siti Zuleka and this is our team.
Saya Nur Farhani binti Cik Idris.
Okay, hi. My name is Nur Syahidah binti Taib.
Hello, my name is Wan Nurin Safia.
First thing first, I would like to talk about what is kernel. So let's check it out. Kernel is the core software component of an operating system. It is also a main component of most computer operating systems. It is a bridge between application and the actual data processing done at the hardware level. The kernel has unrestricted access to all of the resources on the system. So, let's check about the example. As you can see, software, kernel and hardware. Software connect to hardware by kernel. So, kernel is a bridge, iaitu sesuatu medium yang menghubungkan antara software dan hardware. As example, devices that needed kernel such as CPU, memory, and disk to use an application. An application are needed and used by human. So, let's proceed to next topic.
Question 2 is, what is shell? A shell is software that provides an interface for users of an operating system to access the servers of a kernel. The name shell originates from shells being an outer layer of interface between the user and the internals of the operating system, the kernel. Question 3a is, explain what is manual-driven system or shell program. Manual-driven system is an interactive computer system in which the operator requests the processing to be performed by making selection from a series of menus. For example, you are presented with a menu. You make a choice, and then the next menu appears on the screen. Most of the software that use have menu interface. It can use many features of the software by working your way through the menu options. Examples of menu-driven system are ATM machine and iPod. For question 3b, explain what is a fully graphical user interface of shell program. Graphical user interface GUI is a type of interface which helps user to interact with electronic devices through graphical icons rather than command line. It refers to everything that is visual in a modern application such as windows, menus, buttons, and more. The GUI components are used to carry out commands like copying data, moving and deleting of files, opening files, and more. Most GUI commands are carried out through mouse. GUI-based operating system is very easy to operate as commands do not need to be memorized. Example of graphical user interface GUI are iOS and Windows.
Okay, soalan nombor 4. Explain network operating system. Okay. Network operating system is like a software that is installed on the server side on network infrastructure. Network operating system ni menyediakan beberapa fungsi untuk mengurus data, aplikasi, security. Okay. Dalam sistem ni, semua komputer dan terminal lain saling terhubung melalui local area network atau inter-network system. Inter-network system is the practice of interconnecting multiple computer network, menghubungkan beberapa rangkaian komputer sehingga setiap pasangan dalam rangkaian yang terhubung dapat bertukar mesej tanpa mengira tahap. Rangkaian teknologi, sistem rangkaian yang saling berkaitan disebut an internetwork. Main objective network operating system adalah allow user untuk berkongsi data, printer access, file dan program on network. Bagaimanapun, istilah network operating system ini dihaskan untuk meningkatkan sistem operasi asas dengan menambahkan ciri rangkaian.
Okay, hi guys. This is question number 5. List several types of network operating system. Okay, next. We can see peer-to-peer network operating system. Peer-to-peer network operating system are computer systems which are connected to each other via the internet software for P2P workgroup. Okay, advantage for peer-to-peer is easy of setup. Okay, disadvantage lack of security that a client server type offer. Okay, saya ingin terangkan peer-to-peer. Itu apa? Okay, dia ialah sistem komputer yang saling berhubung antara satu sama lain. Okay, dia juga mempunyai kelebihan untuk persediaan yang sangat senang lah. Okay, memudahkan pengguna untuk menggunakannya. Okey, kita lihat contoh peer-to-peer. Okey, kita kan ada file. Contoh kita ada file. Okey, kita ingin berkongsi kepada semua orang. Okey, so kita akan menghantar satu file ke satu file. Okey, so mereka akan dapat file yang sama dan maklumat yang sama. Okey, next. Okey, this is client server network operating system. A client server network is a system where one or more computer called client connect to a central computer named a server to share or use resources. Okay, we can see the advantage. New technology hardware can be easily integrated into the system. Okay, the advantage, cost of buying and running a server are high. Okay, client server ni dia ialah sistem yang di mana boleh menggunakan lebih daripada satu komputer. Okey, komputer akan dikenali sebagai client dan central komputer akan dikenali server. Okey, kelebihan dia ialah mempunyai teknologi yang baru untuk perkakas di dalam sistem tersebut. Okey, kita boleh tengok contoh. Ni client sebagai komputer and server sebagai central computer. Okey, client akan request maklumat seperti website. Okey, website itu contohnya YouTube, Google ataupun website lain lah. Okey, server akan mendapat request dari client and server akan proses dan dia akan reply lah servis yang client minta. Okey, dia akan dapat maklumat yang dia nak. Okey, thank you.
Soalan ke-6, 3 major subsystem of operating system. Okay, yang pertama, proses management. Proses management melibatkan pelbagai tugas seperti penciptaan, penjadualan, penamatan proses dan deadlock. Proses adalah program yang sedang dijalankan yang merupakan bahagian penting dalam sistem operasi moden. The operating system must allocate resources of each process from other methods and allow synchronization among process. An operating system does the following activities for processor management. First, keep track of processor and status of process. Program yang bertanggungjawab untuk tugas ini dikenali sebagai traffic controller. Second, memperuntukkan pemproses CPU untuk proses. And last, deallocate proses bila tidak lagi diperlukan. Kedua, file management. File management adalah sejenis software yang menguruskan fail data dalam sistem komputer. Ia mempunyai limited capabilities dan dirancang untuk menguruskan fail individu atau kumpulan, seperti dokumen dan rekod khas pejabat. Ia mungkin memaparkan perincian laporan seperti pemilik, tarikh pembuatan, keadaan dan ciri serupa yang berguna di persekitaran pejabat. File management is normally organized into directories for easy navigation, and usage directories ini mungkin mengandungi fail dan arahan lain. An operating system does the following activity for file management. Keep tracks of information, location, users, status. The collective facilities are often known a file system. Decide who gets the resources, allocate the resources, and deallocate the resources. Next, memory management. Memory management adalah bentuk pengurusan sumber yang diterapkan pada memori komputer. Keperluan utama pengurusan memori adalah provide ways to dynamically allocate portion of memory program at their request. Ini sangat penting bagi sistem komputer yang maju.
Okay, hi guys, welcome back. Okay, this is question number 7. Examine hardware compatibility and minimum requirement for installation of a particular operating system. Okay, next we can see the system requirement and hardware requirement. So, to be used efficiently, all computer software need certain hardware or other software resources to be present on a computer. Then, most software define two sets of system requirement, minimum and recommended. Okay, system requirement ni boleh dikenali sebagai keperluan sistem di dalam sesuatu software. Okay, supaya komputer kita ni dapat digunakan lebih lancar lah. So, pengguna dapat digunakan. Okay, software ni akan ada dua set keperluan. Dan contohnya minimum and recommended. Okay, then we can see the hardware requirement. Hardware requirement, the most common set of requirement defined by any operating system or software application is the physical computer resources, also known as hardware. A hardware requirement list is often accompanied by a hardware compatibility list, HCL, especially in case of operating system. Okay, hardware requirement ni keperluan untuk perkakas lah. So, tahukan perkakas tu di dalam sesuatu komputer. Perlu ada RAM, CPU, processor, memori dan lain-lain lagi lah. So, dia juga sebelum memasang sesuatu software, dia akan bagi hardware compatibility list. Okey, dikenali sebagai list perkakas lah. Okey, kita akan tahu apa itu list dia. Okay, we can see next. For example, system requirement for installing Windows 10. Okay, sebelum pemasangan Windows 10, kita perlu tahu hardware dia dan spesifikasinya. Okay, we can see processor. The specification 1 GHz or faster processor. Then RAM 1 GB for 32-bit or 2 GB for 64-bit. Then hard drive space 16 GB for 32-bit OS or 32 GB 64-bit OS. Okay, for graphic card, DirectX 9 or later with WDDM 1.0 driver. Okay. Display 800 and 600. Okay, then internet connection. Internet connectivity is necessary to perform updates and download and take advantage of some further. Okay, ni ialah sistem untuk memasang Windows 10. Okay, sebelum tu kita perlu tahulah apa proses-proses dia dan boleh tak untuk install di dalam laptop kita. Okay, thank you for.
Okay, last but not least, from me, Siti Zulaika Azizi, we will discuss about operating system structure. So check it out. Operating system structure have 4 different structure. It is monolithic system, layered system, client server model, and virtual machine. Monolithic system. It is the earliest and the most common operating system. Each component of the operating system was contained within the kernel. It is communicate directly with any other component. Monolithic also have unrestricted system access. By using monolithic system, operating system become highly efficient. Okay, as example, there is 2 space. It is user space and kernel space. In user space have application, and in kernel space have system call interface and any other software. And this is, as you can see this is direct communicate between user space and kernel space. This make operating system highly efficiency within any obstacle. Everything have cons and contra. Now you can see this advantage of monolithic system. As monolithic kernel group components together, therefore difficult to isolate the source of bugs and other error. Systems with monolithic kernel tend to damage by erroneous code due to all code execute with unrestricted access to the system. Now next we will discuss about layered system. Operating system become larger and more complex. Layered work by grouping components that perform similar functions into layers. Each layer only communicates to its immediate upper and lower layer, more modular than monolithic operating system. The implementation of each layer can be modified without requiring any modification to other layers. Example, Windows XP and Linux. Modular is an approach that subdivides a system into smaller parts that can independently create and then use in different systems to drive multiple functionalities. Each layer communicates only with the layers immediately above and below it. Lower level layers provide service to higher level ones using an interface that hides their implementation. By modularity of layered operating system allows to implementation of each layer to be modified without requiring any modification to adjacent layer. Accessories layer approach overcome monolithic design by grouping components that perform similar functions into layers. Each layer communicates only to its nearest upper and lower layer. Lower layer provides service to higher level using interface that hides their implementation. As example, we can see at user space we have application, and kernel space we see different layer level, and we can see each layer only communicate with nearest upper and lower layer only. Everything have pro and contra. Layer also have weakness. In layer approach, a user process request may need to pass through many layers before it is serviced. Additional method must be invoked to pass data from one layer to another. Performance degrade compared to monolithic, which require only a single call to service a similar request, tend to damage the erroneous code because all layers have unrestricted access to the system. Now we proceed to client-server model, or we can say server OSES, are designed from the ground up to provide platform for multi-user, frequently business-critical networking application. Server OSES provide a platform for multi-user application, and most come bundled with a batch of common server applications such as web server, email agent, and terminal service. A thin client, sometimes also called a lean or slim client, is a computer or a computer program which depends heavily on some other computer to fulfill its traditional computational role. The most common type of modern thin client is a low-end computer terminal, which concentrates solely on providing a graphical user interface to the end user. Now, we see common application for server OSES. First, file and printer sharing. Second, application service. Third, website service. Fourth, email, groupware, and messaging. 5, terminal serving. And 6, chatting. Last but not least, we have virtual machine. A virtual machine takes the layer approach to its logical conclusion. It treats hardware and the operating system kernel as though they were all hardware. A virtual machine provides an interface identical to the underlying bare hardware. Virtualization gives an illusion of multiple machines, completely hardware and operating system. The operating system creates the illusion of multiple processes, each executing on its own processor with its own memory. Next, we continue with the resources of your physical computer are shared to create the virtual machine. As CPU schedule can create the appearance that users have their own processor. Spooling and a file system can provide virtual card readers and virtual line printers. And a normal user time sharing terminal serves as the virtual machine operating console. A key enabler is VMM, Virtual Machine Monitor. The virtual machine concept provides complete protection of system resources since each virtual machine is isolated from all other virtual machines. This isolation, however, permits no direct sharing of resources. Okay, now look at the example. Look, A is non-virtual machine, meanwhile B is virtual machine. Now you can see the difference between non-virtual machine and virtual machine in this example. Okay everyone, thank you for watching our video. We hope you enjoy watching our video. And don't forget to like our video, okay? Thank you very much and goodbye.